o'clock.
Good morning po.
Okay, last time, last meeting, we've started the work energy and power, and we were able to discuss the concept of work and energy. But before we continue this, I would like to remind again the class that we will be using the concept of the previous lessons in this lesson on work, energy, and power, particularly the post diagrams, convenient access, and equation of the second law. Based on the result on the midterm exam, there are still some members of the class that don't understand some concept of some of the forces involved in determining the net force, particularly managing the vectors, how to attach the force in the object of interest. The most important quantity or object that we will be tracing or following the motion is this object of interest. We will be concentrating on that object or body where force is applied. So always situate that if you encounter any problem or system, always locate where is the position of the object of interest. After identifying the position or location, you check if there is force acting on the object. Okay, this is only a review on the previous lessons. So I expect at this time you are already comfortable, or you must already understand how to attach a particular force on the object of interest. Again, I would like to remind again the class that before attaching a force or a vector on the force diagram, supposing the acting on it must act on the body. Always situate that you read the definition of the force. Because if you're not reading the definition of the force, you just guess how it is attached, that is not correct. So if you're not sure, for example, you will be attacking the force weight of the body. So you go back to the definition of weight. It is a force which is directed towards the earth. So that will guide you. To that, you will not guess how the weight is attached. Also friction. The definition of friction is it's the force that opposes the motion of the object. So you have to understand now first, where is the object of interest directed or going. You can attach the friction force. That is, it opposes the motion. So you will not be guessing. If you understand the direction of motion, just reflect the opposite. I'm telling this because I observe in the answers, some of the members, they answered just draw in the vector or the force without understanding. Some members of the class reflect the friction same direction as the acceleration. That's wrong. Okay. Before we continue the topic on work energy and power, do you have any question with regards to forces? Remember, every time we have problems to solve or to attend, you must understand first. Okay. For example, in the previous midterm, okay, in force and motion, the coefficient of friction is given, okay, but in the force diagram, it is not, friction is not reflected. So that means this problem was not understood. If meron ng given friction or coefficient of friction, 100% there is friction force involved. Also, if the system in the problem mentioned materials used as rope, string, or cable, there is tension. So, this concept of forces are always written in the definition. So please, if you did not understand force and motion and statics, you ask. Okay. Okay, let's proceed on work energy and power. Last time we have the definition of work. It is force multiplied by this displacement. And the formula is F times S, cosine theta. Formula for energy, kinetic energy is 1/2 mv squared, and potential energy is mgh. We have covered before that work energy uses the same unit because they are the same. Work is the amount of activity or job to be performed, and energy is the ability to do that job or activity. We also covered the conservation of energy. All forms of energy are conserved. Pag sinabing energy, there is conservation. Conservation means no energy lost or destroyed or created. There are only changes or transformed to other form. That is conservation. Okay. By the way, before we go to that topic, I would like to get the attention of uh, Group 2. Okay. They submitted the report on Activity 4. The leader is Ivan Pangantihon. Is Ivan around?
Wala pa po, sir.
Okay, this is the report of Group 2, okay, on statics. Please listen how to fill this heading. Okay. You have to write the title. Meron na nga group activity number 4 dito. The title is group activity number 4 din. This is a problem of statics. So ang title is statics. Okay. Now, the concept of statics that we have covered in the lecture, okay, are not is not followed according to the procedure. Okay. So in solving the problems like this, okay, you have to understand what is this problem. Paano mo maintindihan to? You have to write what is given first. O dito, what are these quantities? Ano itong pinaglalagay dito? Are they given or what? Okay. Okay. Also, I observed we have a module. I'm sending the copy of the lesson to each all members of the class. Now it seems the notations are not followed. Notations on the modules not followed correctly. Okay. Now, if you are writing the like this given data, okay, you base the length of the uniform pole is 20 feet. Okay, so this is L. W of the weight of the pole is 80 pounds. There, W. Okay, and the boy is exerting a force 2 feet from the one end. So this 2 feet. And 5 feet on the other end for the other boy. Okay. The man. The boy and the man. Okay. So you should identify what is F sub 1. That is the force exerted by the wala na. F sub 1 is for the boy. F sub 2 is for the man. You must be, in writing the given data, it must be clear. No, don't just put F sub 1, F sub 2. Okay. You have to identify. Now, there is a condition here. At what point should the load of 100 pounds be placed so that the man will carry twice as much weight of as the boy? So if you identify the F sub 1 and F sub 2, this is for the boy, this is for the man. Okay. The force exerted by the man is F sub 2, which is 2 F sub 1. So that must be reflected. Ito, okay? So you must make this equation clear. So F2, F sub 2, that is the force exerted by the man, is twice the force exerted by the boy. So that's clear. And this question mark, ilagay ito required. Okay. So the figure is written already and reflected already. What are the general formulas? Okay. So the formula that will be used here is formula for the first condition, algebraic sum of f equals 0, and letter B, algebraic sum of L equals 0. That must be the arrangement. Okay. So starting for the first condition, ano itong mga ito? Okay. So maybe you are referring these are the formulas. Hindi ganito ang formula yan. Okay. The general formula is the algebraic sum of f sub x equals 0. I-equate ng 0. Do not just this one. Ayan ilagay formula doon. Okay. Tsaka ito. Di mo in-equate yung 0 dito. Nasaan yung 0 rito? Okay. Also, in the second condition, L equals F times L. Bakit L ang ginagamit dito? S ang momentum doon sa module. Okay. It should be L equals F times S, where F is the force, S is the moment arm. In the formula for the second condition is algebraic sum of L equals 0. So if you write this formula, you must put the assumed direction. Clockwise positive, counterclockwise negative. So that you will understand bakit naging positive ito. Bakit naging negative yan. Kasi itong sinusunod na direction. Now, there is also lacking points here. Where do you rotate the uniform pole? There should be a point or axis of rotation. So how do you base this now? Saan mo binasa ang what is the axis of rotation that you use? Ilagay dito the algebraic sum of L at point. Ano itong F1, F2? So 60 times 2 feet positive. Anong ginamit niyong point dito? 60 times 2. So ano ko yung 60? Even me, I cannot understand what you are group to solve here. Okay. I asked the members of group 2, anong point ang ginamit nyo rito? Wala yung leader ninyo. How about the weight? Yung 80 pounds, saan ba binasa yung 80 pounds na yan? Then yung 80, ito. 80 times 10 feet. times 10 feet. Kalahati. Yung 100 pounds, saan binase? What's the moment arm? $120 times 15 pounds. 120 pounds times 15 feet. Nasaan yung 120 rito? Ito. Okay. So dito binasa yung ano, this is 15. 10 plus 5. 15. So you did not, group 2 did not understand the concept of axis of rotation. Bakit dito pinili? Wala namang force dito. Okay. In getting the axis of rotation, it must be a point where the force located. Dapat dito, or dito sa center of gravity, or dito, or dyan. So, for the second condition, your solution is wrong, group 2. Okay. Binasa nyo dun sa point where there's no force. Mali na lahat ito. Okay. So, group 2, the rating of group 2 here is not good. So it's up to group 2 to revise the report if you want a better rating. Okay. Nandito ito ang mga members. Okay. Wala pa ba si leader, Ivan?
Wala pa po sir, pero kinokontak na po namin.
Okay, better decide group 2. I want this report to be revised. If you want a better rating, now if there will be no revision next meeting, for the next meeting, ano ba ngayon, Tuesday? So Friday. In our next meeting, dapat before that, the revised solution must be forwarded to. Okay. So ito yung mga members. You must help your leader. Okay. Again, choose the axis of rotation at any point here where a force is located. My suggestion here is you may choose point F1 or you may choose point F2.
Sir, iba pa po ba yun sa force diagram namin?
Okay naman yung force diagram. Ito. But in the second condition, in applying algebraic sum of L at any point, kung gagamitin yung point F1, formula is algebraic sum of L sub 1 equals 0. Yun ang equation. So dito ko yung maglalagay ng pako, then get the torque. Kung ito naman ang gagamitin nyo, algebraic sum of L sub 2 equals 0. Ibig sabihin yan, ito pinili nyo axis of rotation. Kaya yung pag ano sa midterm question hindi naiintindihan dahil hindi mo na inintindi ko anong problem. Uniform pole. So, ibig sabihin yan, merong center of gravity of this pole. It is at 1/2. That is at a 10 feet mark. So, nandito yung weight. Karamihan sa members of the class, they disregard the weight of the pole. Kaya mali na yung post diagram. Mali na rin yung equation. Ang nakakapagtaka doon, tama yung answer. Paano nangyari? The post diagram is wrong. The equation is wrong. The answer is correct. That is impossible. Okay. So, group 2, I let you decide. This must be revised solution must be forwarded on or before Friday. Okay, class? Okay, group 2?
Noted po, sir. Sabihan po namin yung leader po namin.
Okay.
Thank you po.
Okay, last time we have discussed the conservation of energy. As I mentioned earlier, the law of conservation of energy states that no energy is created nor destroyed. It merely changes or transforms from one form to another. Now, this simple pendulum is an example of law of conservation of mechanical energy for its potential and kinetic. Okay. If this pendulum is raised to the maximum position or maximum height, there, the energy here at maximum height, where pag sinabing maximum height, this will be the highest point the pendulum reached. So it will stop here, velocity 0. If the velocity is 0, there is no kinetic energy. Okay. Bakit walang kinetic energy? Because the formula for kinetic energy is 1/2 mv squared. So pag B is 0, walang kinetic energy. But if the height is maximum, the energy here is maximum potential energy, because potential energy is equal to mgh maximum. That is the energy. Okay. So, adding getting the total energy here, which is kinetic energy plus potential energy, and kinetic energy zero, so the total energy here is maximum potential energy. Okay. Now, from zero velocity, it will go down. Velocity will increase until it reaches the lowest point, where the height is zero. So if the height or elevation is zero, there is no potential energy because potential energy is mgh. If h is zero, potential energy is zero. Now, with regards to the velocity from velocity zero here at the maximum height, velocity will increase. Okay? Increase until it reaches the lowest point where the velocity is maximum. Okay? Bakit maximum velocity rito? Kasi aakyat na roon. The velocity will decrease until it reaches the maximum height where velocity is zero. So wala na namang kinetic energy. The potential energy is maximum. So it will go down. From zero velocity, it will increase until it reaches the lowest point. So what will be the total energy here at the lowest point? It is still potential energy plus kinetic energy. But potential energy here is zero plus the velocity is maximum, so plus kinetic energy maximum, which is 1/2 mv maximum squared. So, akit na naman siya roon. Maximum potential energy, kinetic energy zero. Converted to maximum kinetic energy here, potential energy zero. So that is the conservation and transformation of energy. From maximum potential energy to maximum kinetic energy to maximum potential energy, and so on. Now, since the pendulum has a radius of rotation here, so the path of the pendulum is a perfect arc of a circle. Kasi this is a fixed radius. Perfect arc ng circle dito. Yun ang path of this pendulum. Now, how is force and motion related here? There is motion. Okay. What is the object of interest? It is the pendulum, this. So if you draw the force diagram of this pendulum, okay, isolated. Why it's called object of interest? Because there is a force. If this is made of string or rod, there is a force acting on the body. Meron din siyang weight. That is how to select it as object of interest. And what is this motion? It's accelerating this curve. This is the path. So ito na rin ang kanyang path or road. And for straight line motion, ito yung kanyang convenient axis. Ayan. The path or the road of the object of interest. So do not just tell, hindi na related ng force and motion dito. Wala nang object of interest. Wala nang force. There is a force. Okay? So, if the energy is conserved, for example, this is 100 newtons, 100 joules, 100 joules din dito, 100 joules din dito. Okay? because there's no energy destroyed. It is converted from potential energy to kinetic energy to potential energy. Okay. Now, since the pendulum is following a perfect arc of a circle, the energy equation at any point in the arc, on the path, is potential energy plus kinetic energy. So if we assign this as point A, at this point, so the potential energy at point A plus kinetic energy at point A equals the energy here, also equal to the energy here, also equal to the energy at this point. That is the energy equation for transformation and conservation of energy. Do you have any question, class? Any question? Yung ba si Gabriel Collado? Okay. Gabriel, do we have another second session at 7:30, 8:30, at 9 p.m. 9 a.m., you know? Same length. If this first session expires, we will meet at the second session at 9 a.m. Okay, Gabriel? Okay. Noted. Okay, we have an example problem here on conservation of energy. Okay. A body of mass m is thrown vertically upward with a velocity of 25 meters per second. How high will it rise? What is its velocity at the height? 20 meters. Okay. So, first we have to write what is the given, what are the given data. Mass of the body is m. Okay. Okay. It is given an upward velocity 25 meters per second. So those are the given data. So this is the initial velocity. Okay. Required. How high will it rise? Okay. And B, how high is h? This is h. Okay. And B, the velocity at a height 20 meters. So B sub 2 is question mark. So this is the required data. Yeah. Now, what are the formulas? Ilalagay yung mga formula. Okay. Since this, 20 What formula we will write here? Okay. We can write potential energy equals mgh. Kinetic energy K is 1/2 mv squared. Those are the formula we covered in work, energy, and power. You may also add W, that is the work, is equal to F times S. Yun ilalagay yung mga basic equation or formula. Okay. So the figure is this. Okay. The initial velocity is v sub 1. It is 25 meters per second. Now, if this is the body is at the ground, it is given an initial velocity of 25 meters per second. So this will be the maximum velocity because that is the starting velocity. Bakit naging maximum ito? Because as the body go up, because of its weight, the velocity will decrease until it reaches the maximum height or point where it cannot go beyond anymore. Hindi na siya pwedeng tumaas pa. So this is the maximum height. In reaching the maximum height, what will be the velocity? Okay. Pag nakarating siya dito sa highest point, velocity is 0. So dito ang maximum velocity, yan ang 0 velocity. Okay. Since the body started from the ground, so this will be our elevation, h equals 0. Kasi dito siya nag-umpisa. So this will be the elevation 0, h equals 0, and at the highest point, this will be the maximum height. Okay. So we have identified the critical points, elevations, h equals 0 and h maximum. That is related to the potential energy. How about the kinetic energy? Since the velocity here is maximum, the kinetic energy here is maximum. And when the body reaches the maximum height, the velocity is 0. Therefore, there is no kinetic energy or kinetic energy is 0. So, the energy conservation and transformation here is maximum kinetic energy is equal to maximum potential energy. And the equation now is 1/2 mv maximum squared equals mg h maximum. Okay. So for letter A, to determine the maximum height, there. Okay. The kinetic energy at the bottom, which is maximum kinetic energy here, is equal to the potential energy at the highest point. Ito. Maximum potential energy. Now, what are the formulas? 1/2 mv sub 1 squared. Because this is the maximum velocity, so 1/2 mv maximum squared is equal to mg at the highest point times maximum height. Ito. That is the energy equation. So, cancelling m and m, we have 1/2 v sub 1 squared equals gh. And getting the equation for h, you have b sub 1 squared over 2g. Now, what value of G we will use. You go to the units. What system of units used? Meter. So that means the system of units is MKS. Okay, we have the 10 minutes. So MKS is the unit, system of units. So we use G equals 9.8 meters per second squared. That's the value of gravitational acceleration. So in this equation now, the substituting the values, 25 meters per second squared divided by 2 times 9.8 meters per second squared equal to 31.88 meters. So this maximum height is 31.88 meters. That's for letter A. Ayan. So make it a point that if you are solving a problem, identify anong letter ba yun, letter A. Ayun. Do not just solve and solve without identifying what question are you answering. Okay. So for letter B, what will be its velocity at 20 meters high? Now considering that the height is 32.88 dito, and its height here is 0. So if this is approximately 32 meters, ang 20 meters na dito, in between. So what will be the velocity here? Now, by just looking at the figure, okay, since the height is 20 meters, there is potential energy. And since the body is moving or having a velocity, decreasing velocity, okay, between 25 and 0. So there is velocity. Therefore, there is also kinetic energy. So two forms of energy are present on this position. So getting their sum, okay, the total energy here is potential energy at point 2 plus kinetic energy at point 2 equals, you have to equate it here or there, okay, because energy is conserved. So here, the kinetic energy, this is the total at this point is equal to the kinetic energy at point 2 plus potential energy at point 2. Okay. Now, which energy should be used here? Maximum kinetic energy or maximum potential energy? You can choose any of this. But the better energy to be used here is the maximum kinetic energy. Why? Because the velocity is given. Okay. If we use maximum potential energy, it's not practical because we solve for the maximum height. So in case we have error in getting the maximum height, this equation will be affected. So better use this energy where there is given quantity, the velocity maximum. Yeah. That's why kinetic energy is used here. And substituting now, 1/2 mv maximum squared, okay, is equal to 1/2 mb sub 2 squared. So b sub 2 here. Plus mgh sub 2. That is 20 meters. So 1/2 times 25 squared equals 1/2 b sub 2 squared is unknown plus 9.8 meters per second squared times the height 20. So this is the equation. And b sub 2 is found out to be 15.26 meters per second. So let us check if this is correct. The velocity at point 2. It must be between 25 and 0. Okay. So kung 25 dito, the velocity will decrease until it reaches the height of 20 meters. The velocity is 15.26 meters per second. So that's correct. It should be in between 0 and 25. Any question? May tanong ba kayo? Okay, that is how to apply the concept of energy conservation and transformation. In this next example, also conservation of energy because K equals PE. Okay. So it's up to the class not to verify. Okay. At this point, there is potential energy. There is no kinetic energy because velocity is 0. Okay, but here, there is B sub 1, so kinetic energy. Dito naman is, there is no potential energy because H is 0. Okay. And there is conservation. So the other examples in the book, you have to verify and check. Okay. There's still 3 minutes. Okay, the session is expiring. We will discuss power on the next session at 9 a.m. Thank you, class, for attending this first session. See you at the second session at 9 a.m. Thank you, class. Number 5. Okay, do you see the screen?
Yes po, sir.
Okay. We have the term power. Okay. Power is the rate of time rate of time. So there are several formulas for power. Power is denoted by letter P, capital letter P, and it is equal to the work divided by the time. Now, knowing that work is a force multiplied by the displacement S divided by the given time T, so it can be expressed in terms of Fs over T. And also, since S divided by T is velocity, power can be also expressed in the formula force multiplied by the velocity. So these are the different formulas for power. Now again, I would like to remind the class that we must have uniform notation of the quantities according to the module. Okay. Do not use other notation. Okay. For S, that is the displacement. B is the velocity or speed. Okay. Sometimes if you are using notation for displacement like D, that is not according to what we are using notations on this module, on this lesson. Okay, how do we manage power? Okay. The unit of power expressed in the three systems units. Okay. If the given units in the problem or the question in terms of meter, kilograms, second system unit, MKS, the unit of power must be per second or watt, W-A-T-T. Okay. Because joules per second is 1 joule per second is equal to 1 watt. Now, if the units used in the problem in terms of centimeter gram second system unit, CGS, unit of power must be in erg per second. And in the English system or British system of units, what are the units used there? Foot or feet, mile, okay, yard. So those are under English system of unit. So the unit of power must be horsepower, HP. Now, in converting unit of power to another unit, either English or British or MKS or CGS system units, we use these conversion formulas. 1 horsepower equals 33,000 foot-pounds per minute. And dividing this by 60, it becomes 550 foot-pounds per second. 1 horsepower also is equivalent to 746 watts or 0.75 kilowatt because 1 kilowatt is 1,000 watts. So these are the conversion formula. Now there are problems here, like in the problem number 1, the units used here are in pounds, foot, or feet, and minute. Okay. So this system system of unit is English or British system of units because of this fit. So, according to the statement here, if the unit is in the English system, the power must be expressed in horsepower. Yeah. But it seems the author did not follow this statement here. Should be power must be expressed in horsepower. So this must be converted to horsepower using the conversion factor. 1 horsepower equals 33,000 foot-pounds per minute. So by converting this, you multiply this by foot-pounds per minute in the denominator, which is 33,000 foot-pounds per minute. In the numerator will be horsepower. Yeah. So the unit will be in horsepower. In the second problem, the units are also in English. So horsepower is the unit per power there. Okay. In the third example, the unit is in MKS, meter, kilogram, second system of units. So the unit of power must be in watt. Yan. Kaya watts ang ginamit dito. That is how to deal with this term power. Okay. Any question, class? So again, the formulas that we will use in this lesson, work, energy, and power. The first formula is work equals F times S. Energy is, kinetic energy is 1/2 mv squared. Potential energy is mgh. Okay. Power. It may be W over T or Fs over T or F times V. Yan ang mga general formulas we have covered in work, energy, and power. Okay. So you must accustom yourself in dealing with physics problem, laging understand first the problem, then write the given, write the required, draw the figure, reflect the general formulas. Kasi dito kayo mamimili sa formula na gagamitin. Okay? Then solution. Very simple. So we'll go to the assessment question. Okay. We'll have the attendance first. Today is 13. Francis Author, Bautista Gabriel Joy,
Present po, sir.
Ann Benice Biete, Aliana Kakbay,
Present po.
Mikey Caroche, Gabriel Collado,
Present.
AP Del Moro, De La Cruz Paula,
Present po.
Para Estoconing,
Present po, sir.
Jubel Idolsa,
Present po.
Jan Magat, Mapalo Friends, Andre, Jamuel Miranda,
Present po.
Kelly Morales,
Present po.
Tricia Narvesa,
Present po.
Cindy Novora,
Present po.
Roy Oli, Ivan Pangantihon, John Lester Prieto, Jocelyn Recto,
Present po.
Charles Reed,
Present po.
Christine Sanpilo,
Present po.
and Mark Villaseran.
Present po.
Okay. For the next activity, the leader is sandali. Wait. Oh, nagpapa-accept si ito, Charles. Wala naman. Okay. Okay, for the first group, the leader is Jubel Idolsa.
Noted po, sir.
Okay. Ikaw ang leader ng first group. Group 1. Activity number 5. For the second group, the leader is Jocelyn Recto.
Okay po, sir.
Okay. John Lester Prieto.
Hi po, sir.
Okay. So for the first group, the activity question will be number 4. And for the second group, it will be number 7. So these are conservation of energy questions. Okay.
Sir, sino po leader sa ano? Group 2.
Group 2 si Jocelyn Recto. Jocelyn, ang activity question is number 7.
Opo, sir.
Okay po, sir.
Leader ng group 1 si Jubel Idolsa. Okay. Group 1, this is about a projectile. So you have to refer to the topic projectile in getting the maximum height. Kasi the projectile is fired from a cliff. The height of the cliff is 125 meters. So kung ito yung cliff, pababa, okay, the projectile is fired. Pag ganon. There. Hanggang mahulog siya doon sa ground below the top of the cliff. So kailangan makuha yung maximum height. from the cliff tapos sa plus the ground. Okay. So to get the maximum height, merong formula doon sa velocity and acceleration lesson about projectile. Okay. Yun ang magiging figure ninyo. Dito naman sa group 2, Jocelyn. Okay. So, snow-covered peaks. So, may dalawang peak. Isa rito mataas. Sa kabila is mas pababa, 741 meter. Now, there is a valley between these two creeks. So, ang magiging figure ninyo is it will be a perfect arc of a circle. Ganon. Pag makikita nyo yung simple pendulum, ganon ang kanyang path. Yung iba kasi mas mataas, yung isa mas mababang cliff. Peak. Okay. So it is covered with snow, kaya smooth yung path ng skier. Nag-ski. Okay. That is how to draw the figure of number 7. Okay. Any question? Group 1 and Group 2?
Sir,
Yes.
kailan po submission nito?
3? Ang deadline?
Yes po. Kailan po deadline?
Ilan po bang meeting tayo? Sandali. Today 13, ang last day natin is of this year is hanggang 20 yung sa schedule sa calendar. So di-discuss sa sa um, 20. The Tuesday. Did you get that? Group 1 and Group 2?
Noted po, sir.
Yes po, sir.
Okay. The last experiment that we performed is experiment 2. Okay. On Friday, we will perform experiments. Okay. Medyo behind na tayo. Number 2, that is uniformly accelerated motion. So we will have experiment, maybe dalawang experiment ang ipaperform natin sa Friday. Experiment 3 and 4. Madali lang naman yon. Okay. I am reminding those who are not attending the actual application of the lessons that we are covering, like the experiment. Okay. Yung mga nag-absent, as I have mentioned before, if you are absent in that activity, wala kang grade doon sa activity. I am getting the attendance. Okay. Although you are listed by your leader doon sa attendance report, okay, nagtataka ko minsan na it's not my attendance in the laboratory, my record is not coinciding with the report, attendance report. So I'm reminding those who are absent in a particular activity or experiment, you will not have any rating for that particular experiment if you are not attending. It's very important for you to attend this actual application. Kasi doon malalaman how to apply the theory that we have covered in the actual application. Okay. So please try your best to attend the experiment activity next meeting, and that is on Friday. Do you have any question, class? We will try our best to finish the experiment applied to the theory that we have covered. So if we can finish the experiment next meeting, tatapos na tayo ng application of force and motion and statics. Okay. So that hindi niya next year medyo relax na tayo sa experiment. We must be according to this schedule. Okay. Any question, class? So, as I mentioned earlier, okay, the concept that we have covered in the previous lessons are still being used in the succeeding lessons. So, try your best to review again the previous topics or previous lessons. Gabriel, do you have any concern in your class, in your section?
Wala naman po.
Any question from the other members of the class? Okay. I observe still, sinasabi ko palagi, some members of the class are not fully understanding the concept of the force and motion and statics lesson. If there is any point on those lessons or topic that you did not understand or not clear to you, please ask for clarification. So if there are no more questions, I think that is for this meeting. Thank you, class, for attending this second session. Hope to see you on Friday for the experiments. Stay safe and have a good day. Thank you, class.